So to continue on here, what we're doing is finding the equilibrium level of traffic volume, and what we need to do is just start with our equation for demand for travel, which was V equals 16 minus P, and we'll substitute into this P the private cost of travel. So the cost of travel that each individual considers when he's not considering the cost he imposes on others. So what we'll do is we'll write V is equal to 16 minus, and for P we'll insert this term, which is the private cost. So 4 plus 2V. And that equals 16 minus 4, and we'll open the brackets, minus 2V. Put the V over there, and I'll add 2V to both sides, so I get 3V is equal to 12. And then I'll divide both sides by 3. The 3 there cancels out, and this turns into a 4. So we get V is equal to 4. Alright, so we can fill that information into our chart. V is equal to 4. And so what is the price when volume equals 4? Well, we can use either one of these curves. We can use the demand curve or this supply curve to find out what the price is when V equals 4. After all, they both cross at this same point, and so we can use either curve to find out this information. So I'll show you actually how that might work. So you could use private cost equals 4 plus 2 times V, and in this case V is 4, to find out that private cost at that point is equal to 4 plus 8, which equals 12. So let's put that information in, and just to show you that it can be done another way, let's use the demand curve. So V equals 16 minus P. V equals 16 minus P, and we know that V is 4, so we'd write 4 equals 16 minus P. And I'll add P to both sides, so P plus 4 is equal to 16, and then I'll subtract 4 from both sides. So P equals 16 minus 4, which P equals 12. So in both cases here, we found out that the price, the relevant price, should equal 12 when V equals 4. Good. So that seems simple enough, I think. Now the next thing we need to do is find the optimal level of traffic volume. So we found the equilibrium traffic volume and the equilibrium price that corresponds to that amount of traffic volume. Now we want to find the optimal amount, and that is given by this location here, where this second supply curve, which takes into account the cost that individual drivers impose on others, and we'll find out where that intersects with the demand curve. So I'm just going to clear some space because we don't need a lot of this stuff any longer. Okay. And again, we're going to use the same technique that we did before, where we have our demand curve V is equal to 16 minus P, and instead of using the private cost to substitute into this P right here, we're going to use the marginal cost, because that's what this curve here represents. So we're going to use 4 plus 3V. So we're going to say the demand curve equals 16 minus, and then the price, which is 4 plus 3V. we'll just work out what that is. So V is equal to 16 minus 4 opening the brackets, minus 3v. I'm going to add 3v to both sides, so we'll get 4v is equal to 12. Divide now both sides by 4 to get rid of that 4. Then we'll end up with v is equal to 3. Good. So we can input that information into our graph. V is equal to 3. And then we need to find the price that corresponds to that level. So what we can do, same as last time, is use this marginal cost curve to find that, or we could use the demand curve given by this equation here. So we'll actually use both just to prove that once again it can be done. So if we have marginal cost, which is corresponding to the price on the y-axis here, is equal to 4 plus 3v. And if v is equal to 3, then we can say 4 plus 3 times 3, which is 4 plus 9, which equals 13. So we can input that information on the y-axis. And let me just clear some space once again, and I'll show you that you can do it using the other equation as well. So if you have v is equal to, I need another color, v is equal to, what is it equal to? 16 minus p, and we know that v at this level is 3, then we can substitute that value in, 16 minus p. And if we add p to both sides, we get p plus 3 is equal to 16. Now we want to subtract 3 from both sides, and we get p is equal to 13. And that's exactly what we found using the other method. Now the only thing left to do is to find the value of the toll, and that is going to be represented by this space right here. This is going to get a little bit messy if I keep using this graph. I might have to draw another one, but I think you'll be able to figure out what's going on. The toll that we're going to need to get to the optimum quantity of traffic, the efficient volume of traffic, considering both private and external costs, is going to be given by this distance right here. And you can think of it as a toll that pushes a wedge between this supply curve and this demand curve, starting at this equilibrium point. So it pushes a wedge in between these two curves until we get to this point. To do that, all we need to do is find the distance between this point and this point. And once again, I'm going to clear some space. Don't need this stuff. Oh, actually, I'm running out of time on this video, so I'll continue in the next video. See you then.